Hi everyone, and thank you for joining. My name is Dimitrios. I'm from Greece, and here are a few things about me. So I'm engaged in computer security since 2002. I was actually a member of one of the first reverse engineering groups back in Greece, and I started my career as a network security engineer. Then I moved into developing for about 5 years, and the last 5 years I focused mainly on Android security. Before I joined Microsoft's threat intelligence team as a senior security researcher, I was leading a team which was conducting malware reviews for the Google Play Store. And besides that, I'm a father of two, a boy and a girl. My free time, I play music, guitar, piano. I also sing, although there is a debate with my wife regarding this one, so I didn't put it here. All right, so before we start, I just want to address a question which I get quite often during my talks. And this is how come a Microsoft security engineer talks about Android, this kind of stuff, how these things are connected. So as I said, I'm following up with computer security for quite a long time. And I guess you would also agree with the fact that today's threats need a more holistic approach, right? So a breach in your mobile might affect even your corporate network right now. And I strongly believe that companies should, improve their security solutions in order to protect their clients across all platforms. So I'm very proud of being a part of, such an initiative. And with that being said, we can jump right to the outline of this briefing, which consists of the following topics. So first of all, we're going to talk about the Android user interface, just a brief overview of the main components, things that we're going to use during our presentation. And then we're going to go to, first main part, which is GUI Confusion Attacks. What is the story so far? We're going to see quite a lot of, techniques which have been presented during the last years when it comes to Android operating system. And then we're going to discuss about the behavior out of which this attack was, inspired. Okay, then universal overlays addressed by the specific CVE. Actually, the title is Permissionless universal overlays, but it's quite far. Couldn't add it here. And we're not going to use any kind of permission. This is the difference actually with the attacks that have been presented so far. And finally, we're going to see some defense takeaways, how we can protect Android apps from these or even similar type of attacks. Okay, so let's start with, the Android graphics architecture, focusing on the components that we said we're going to discuss. And I'm not sure how many of you have created an Android app so far, but we may all agree on the fact that one of its most important features is the ability to interact with the user, right? So that being said, almost every modern development environment facilitates this process by providing tools to make this process easier, right? So this way, an Android developer with just a few clicks can add or remove buttons, views, images, and so on without need to dive deeper into their implementation details. Now, system-wise, when an app is created, a window is going to be attached to it, which is actually a container for what we call view objects that are backed up by surface objects. And since we may have more than one app running at the same time in an Android device, what comes next is the surface flinger, which will gather all these surfaces and try to compose them onto display after talking with the hardware composer, which is a hardware abstraction layer, which will gather all these surfaces and do the final composition of the display. Now, what I intentionally didn't mention so far is the role of the window manager. So for whom, is to decide the order, the focus, the position of the windows in an Android display. And this is the window manager, where the window manager comes into play, which will gather all this info, will send them to the surface flinger, and will do the final composition, as we said before. Now, when it comes to the window manager, it's an Android system service, which is, responsible for the look, the behavior, but also the behavior of the windows, and also the transition, the animation of them when we open a window, when we close one, or we're simply rotating something. Although, despite the rich functionality of this system service, third-party apps don't have access to the raw IDL. And they can actually, access specific properties using some classes like the window manager, or the view configuration class. And here I have an example of let's say, how you can acquire an instance of the window manager, then access these properties, as I said before. Now, another important aspect, which is related to our research, is what we call Z-order, and refers to the order across an imaginary axis, which starts from the bottom of the screen up to what the user sees on top of the screen, right? And the position of a window in this axis depends on its type. And every Android app can request a window type, any window type, by just creating a window manager instance, acquiring window manager instance, using the layout parameters, and then just setting the window type that it wants, right? Finally, you can use add view in order to add a view to the newly created window. What is now strange here is that, let's say, privileged window types, and by privileged I mean the ones which are on the top of this imaginary axis, come with special, let's say, with high price. Let's put it this way. So in order to get approved such a window, for example, the type alert window, you need the system alert window permission. So the user has to go to a specific menu, enable this, let's say, permission for your app in order to get this window, this permission approved. Now, what happens here is that before Android 23, this permission was approved by default. SDK 23 was approved by default. And what is even more interesting is the fact that if an app targets an SDK which is lower than 23, gets permission approved by default, even in newest Android versions. And this brings me to the figure which I have here on the right side, where you can see the various window types and their position across this axis that I talked to you about. And despite the fact that most of these window types have been deprecated or aggregated under a single window type, they can still be used by apps which are targeting, let's say, these are versions up to Android 8. Okay? All right. So we talked about the look of a window, how the shape and all these things. But there is also another interesting, let's say, aspect when it comes to windows, and this is the behavior of a window. And what I mean by that is how it will, let's say, react on various events that take place on an Android screen. So the common, let's say, behavior in that case is that the window will consume the specific event. So what this event can be is, let's say, a user click or a user touch, a swipe. So what will happen usually is that the window will consume this event, will perform some kind of functionality, and that's it. But you can change that using various flags, like the first one that I have here, which is the flag not touchable. So what you can do with that, you can simply let your window dispatch the touch to the window which is below, right? So we give this way click-through capability to our window. That's so simple. And to use this flag, you don't need any kind of permission, right? Just to make clear. All right, so we said about the look, we said about the behavior. And there is also another interesting, let's say, feature when it comes to these windows, which we'll call them free-floating windows. So they depend solely on the process that they belong to. So what that means is that even if you have created your window within your activity, and you dismiss this activity, this window will remain there as long as the process is still active, and the other way around. And this is actually something which a lot of malware families are using in various ways. For example, a ransomware, they're using this type of windows to cover the screen so the user loses access to the actual user interface. And like I said, this is just one way to abuse this type of feature when it comes to this type of windows. All right, so okay, let's make a pause here and try to identify what is the main issue, right? So we said that actually, yeah, the Android is an operating system where more than one app can run at the same time, right, in the background. And we said that each time only one app will be the one that will be interacting with the user. We have a couple of protections when it comes to the origin of an APK. We have the signature, which can be used to authenticate an app and, ensure that it comes from the same developer. And we have also what we call the trusted sources, which can ensure that an app, let's say, meets some specific criteria. Although there is no explicit information showing to the user about the user interface that interacts with, and the application that it belongs to. So that's the main problem. And this way, any app can imitate the user interface of another app and claim its identity or claim legitimacy. So in most cases, the victims of this, let's say, type of behavior are banking apps or apps in more general which handle some kind of financial data of private info and so on. All right? Okay, so, and this brings me to the main, let's say, to the first main topic when it comes to this type of attack. And we are going to start from the obvious. GUI confusion attack needs some user interaction, which needs sometimes social engineering. And in general, attacks which depend on this type of, let's say, vulnerabilities, they are considered as low-hanging fruits when they are compared with attacks which depend on memory corruption types and so on. But this is kind of unfair if you consider the fact that almost every modern malware campaign like, let's say, Flubots, Cerberus, all these, let's say, modern, in a way, families are using this type of attacks in order to achieve their targets, right? For example, the ones that I mentioned, they're using overlays in order to perform phishing or something. So, despite the fact that many, let's say, techniques have been presented quite the last few years when it comes to GUI confusion attacks, we may, let's say, classify them in three main categories. So we have the first one, which we're talking about attacks that they are using overlays. And then we have the ones they're using task hijacking. And finally, we have the ones which are using what we call activity switching. So starting with the first one, the main idea is to conceal a part or all of the message which is communicated to the user via a graphical user interface in order to alter the message, to alter the meaning of this message, and trick the user to take an action that wouldn't normally take. For example, imagine that we have a fraudster which offers a service, offers a product, and sends a request to the user. A top-up, let's say, pops up from a banking app. The user sees the amount, which might be very large, extra large, and the user will reject because the amount was, let's say, insane. If the same attack will be performed from a malware which can create overlays, then the amount can be simply concealed, so the user can be tricked and, let's say, approve the request. So, as you understand, from what I've said so far, the rogue APK, the malware, must be able to control the position of a window in this imaginary axis that I talked to you about in the beginning of this briefing. And one way of doing that is using what we call a type toast window. This isn't an old attack, Anyway, it uses this type of a window, which window by, let's say, construction was created in order to be on top of other apps. Why? Because it has to send a message to the user to take a quick action or something is happening, some kind of an event. So the user has somehow to take an action. So this type of a window, as I said before, should be on top of others. And this is something that this attack, let's say, abuses. Again, create a window manager instance, layout parameters, and this type just use a type toast window, add click-through capability, change transparency, position, and finally perform the final overlay. The same thing, the same result, different type of a window. This actually was used by the Clock and Dagger, let's say, technique. Use a type system alert window or the newest version of it, which is the type application overlay, although, again, the user has to navigate to this specific menu and enable it in order for an app to be able to do that. Yeah, this. Another attack, which is not that widely known, it was actually my first 0 day, this one, so this is why I mentioned that. So it was first found in the Flavor 99 adware, and what this adware was doing was just loading a library, a native library, and was giving a couple of constants which was to a function which was implemented in the native layer. So these constants were found to be to represent window types. The one was the type presentation, and the other one was the type toast. The type toast I talked to you about, but the type presentation was, let's say, something like an overlooked type of a window. Someone didn't notice something, so I don't know. And it could create overlays without any kind of permission. So it was giving these values in, let's say, some native implementation of it. And then it was creating again a window manager instance, checking if the SDK version was lower or equal to 24 in order to create a type toast window or a type presentation. So that was it, how it was using that. So in Android 10, there was a restriction which says that an app can't start an activity from the background if it doesn't have some specific, let's say, if some specific conditions apply. One of these conditions was if the app has a visible window in the foreground, then it can start an activity. So this one was using exactly for this way, it was using this, let's say, window type. So it was creating a window which was invisible. All right, so it was not visible to the user, but it was visible for the system. And it was using this window in order to start spamming the user with advertisement. So that was the main, let's say, way of using that. And you can understand by using just a 0-day in order to spam the user for what kind of revenue we're talking about when it comes to this type of malware. All right, next one is task hijacking. And in computing, when we're talking about multitasking, we refer to a state where more than one process can run at the same time, right? Although when it comes to Android operating system, a task has a slightly different meaning. So a task is not an app, it's not a process, it's a set of activities that the user interacts with in order to do some kind of a job, right? That's the meaning of it. Now, these activities may belong to different apps, and activities may belong to different tasks. So that's the idea, and this, let's say, attack abuses state transition conditions like the task affinity and the allow task reparenting in order to do that. So how it does that? Imagine we have the victim app, which is a completely secure app. So the adware, malware, whatever, will create an activity which will set the task affinity to the package name of the app. It will set actually the flag of this activity, allow task reparenting to true, and then it will try to, let's say, inject itself to the task that the user interacts with when it comes to the specific app, right? That was the idea about this one. And the last one, which is very interesting, although it's very, very simple, abuses APIs which are used in order to bring an activity on top, on the foreground, right? So the idea is, again, simple, observe the foreground. If the activity which is currently on top belongs to our target list, then start our own activity and hijack the user session. That's it. We have a couple of exceptions, a couple of restrictions when it comes to this, let's say, attack. So we don't have visibility of the activity which is on top. Right? We have the sandbox. We have a lot of things when it comes to Android. So we don't have visibility regarding that. And we can't start an activity from the background, as I said before. Exceptions, accessibility service, the powerful accessibility service which can be used actually to get your app opt-out from almost any kind of UI restriction. We have the user stats. When it comes to the first one, the system alert, for which I talked to you about. And we have the full screen intent, which never works. I don't know why. But I added here just for the sake of completeness. Now we are going to see the first demo. I have quite a few because we're talking about GUI confusion attacks, so it makes sense. So I created a rogue APK which performs this task activity switching attack. So what it does, it will observe the foreground. If the app in the foreground belongs to a very, very well-known, let's say, banking app, it will start its own activity. So I hope it will play. Yeah. Yeah, that was it. Anyway, so not much, just few things about the context here. So first of all, as you may notice, there is a small window here, on the left side, which is a free-floating window, which is used exactly for the reason that I talked to you about. It's a foothold. So it uses this foothold, observes the activity which is on top, and if the activity belongs to the banking app, it will start its own activity. So the user will start, let's say, interacting with the malware instead of the banking app. That's the idea behind this one. All right. So we said that we can use a start activity method in order to start an activity. obviously, and this can start another activity, the new activity can start another one, and so on. But the question here is how these activities are arranged on the screen. So, and the answer is that they are using what we call a backstack. So imagine something like a last in, first out stack where the user can simply add or remove activities from the top of this, let's say, stack by simply interacting with the user interface. Now, what is interesting here is the fact that when an activity is pushed in this stack, it will retain its graphical user interface. And what is even more interesting is the fact that if the user starts another task, let's call it task B, task A will go in the background, and the backstack will remain intact. So when the user removes task B, task A will get again the foreground, and the backstack will be restored. So what I just described can be exceptionally visualized by using a transparent activity. And how we can create one, we just create a theme which has, a transparent window. The background, which is the color, actually, it is also transparent. We don't want any shadowing, title. A window is floating means that the window is not anchored, so it can be moved freely. And finally, we have the background dim enabled set to false in order not to blur the activity which is below. That's the only thing that this flag is doing. The next thing was just to choose an app which has some kind of emotion, right? We wanted to understand the level of intactness, what they mean by intactness. Will the app still keep playing the video, for example? That was the question. Right, and this was the result, the second, I guess. Yeah. Anyone notice something? Yeah. Yeah, actually the result actually was so good that I myself had to add some kind of a mark in order to understand with which app I was interacting. Was it the YouTube app or was it my app? I mean, so I added this one, and then my next, let's say, thought was to do something a little bit more, let's say, malicious. And I did this one. So if you desperately wanted, let's say, a YouTube Premium account, would you click on this one? This is a question here. I don't know. Any feedback? Yeah, anyway, yeah, I don't think that you like a YouTube Premium account. But in any case, I think that the main idea here is that you can integrate the user interface of the activity which is on top with the activity which is below. And by adding, let's say, some specific, let's say, views or effects or something, you can even alter the user interface of the activity which is below. So that's the main idea behind, let's say, this attack. But there are a lot of restrictions again, right? We don't have visibility. We talked about that. We can't start activities. We talked about that. And we don't have click-through capability. We can, of course, we can bypass all these things, or we can, to put it better, we can get our app opt out from these restrictions by using permissions, but our attack wouldn't be permissionless if we had permissions. All right, so before I explain how we managed to amplify what we had so far, in order to get a practical, let's say, create a practical attack and get some security impact regarding this attack, let me first describe our targets. So we're targeting critical importance screens which can be used in order to request from the user to take some kind of critical decision. And so when it comes to third-party apps, we're talking about apps which can be used in order to approve a payment request, a remote login, or some kind of an authorization or something. When it comes to system screens, which is the most interesting in this case, we're talking about the screens which can be used in order to approve permissions, dangerous or no, system services, privileged access to system privileged services, or change some kind of a setting. And we may classify those screens in two main categories. So the first category is the single-step decision screens. Simply said, a window will pop up, the user will click on the window, and a decision will be made. And we have the multi-step decision screens, where the user has to follow, let's say, some steps and some wizard in the Windows OS, in order to get to the final, let's say, screen and click something in order to get the final decision made, right? So let's start with the first one, which is the first line of defense of the Android operating system when it comes to private user info. And this is the permission screens. And when I say about permission screens, we are talking about the ones which control access to user private info, like SMS, call logs, you name it, the contacts, anything. Or even devices like the microphone, camera, location, right? A lot of things. So this is the main idea. That was the main idea behind the first, let's say, the single-step decision dialogues. These dialogues, before Android 11 and Android 10, belonged to this package here. And they moved to an Apex, as many more. They moved to an Apex in Android 11. Although OEMs can customize this user interface, these dialogues, using runtime resource overlays. But what we are most interested in that case is what type of window this permission dialog is using. And let's say it was surprised to see that it was using a simple base application window, but it had some very interesting flags. One flag is the dim behind, which can be used in order to blur the window which is below this one, and the other one was the hide non-system overlay windows. And this one is a little bit, let's say, interesting, and I'm going to elaborate a little bit more. So it can be used in order to protect an app from type alert or system alert window type. Okay? And that's the good news. The bad news, up to Android 12 at least, it was that in order to use the flag, the specific flag, you need the hide non-system overlay windows permission, which is a signature or privilege, so it can be used only by system apps. And then this was moved to the hide overlay windows, and now you can use it also from third-party apps. Okay, but if you think about it, if you think about the activity that I show you, the transparent activity that I show you, it doesn't use any kind of special window, right? Special type or something. We use a humble base application window. So the next step was embarrassingly simple. It was just to add a click-through capability. No rocket science here. You get a handle of the window, set the flags to the not touchable, arrange the view in a some way that you can cover the parts that you are interested about, and you have the following result. So here you have the permission dialog on the left side, and on the right side you have the permissionless overlay. So that was the idea, and that was how it worked. To give you some context, our app starts with 0 permissions approved. Yeah, and it ends up with all the permission approved. All right, so that was the, let's say, the main points out of it. I guess the acute viewer may notice the short delay when it comes to the overlay and the permission dialog, but this can be adjusted. This actually belongs to a loop. We just use the loop in order to ask the permissions, but you can adjust the time that you request the permission so you can put your overlay on the right time. All right, so I guess permissions dialogs are cool. They can be used in order to get any kind of info when it comes to private user information, but can we do something better? And the next, let's say, challenge was the multi-step decision dialogues, which can be used in order to approve access to very interesting services, like the accessibility service, or give you access to the files of the device, to the external directory, after the introduction of the scoped, let's say, storage. Then you can get access to, you can get your app as a device administrator, you can get the system alert window, notification access, premium SMS, and of course to install unknown apps. So all these things are, as you understand, quite privileged when it comes to Android. All right, so the first challenge when it comes to this type of, let's say, dialogues was to minimize the steps that the user has to take in order to approve access, to give access, right? So we have to minimize the steps to get to this button there. and make the user to click on this button. But there is a convenient way of doing that. You can just create an intent, set the action to the corresponding menu that you are interested about, and you can start the activity in order to navigate the user to the menu that you want. For example, you want to get the user to the manage overlay display on top, you can just create the first one, accessibility service the second one, and so on. Right? So that was easy. But we still have 2 steps. The first step, the user has to choose our app within in a list actually, which with apps which request the same type of access. And the second step is, of course, to trick the user to click on this button there. But if you notice the first list, the activities, actually the packages there, are arranged in an alphabetical way, right? They are ordered alphabetically. So the only thing that you have to do is just to name your app, I guess, with some A's, like we did here, AA. So that explains the name. In order to predict the position of our app in this specific list, because it's very important, right? So the next step was to create a rogue APK, which will simply start the first menu, this one that you see here, and then start an activity which will cover the parts that we're interested about. So we can just focus the user only on our own app. So that was the first step. And then use a trampoline activity. I will explain why I named it like this. In order to start another overlay, which will cover again the parts of the dialogue, of the second dialogue, that can be used in order to, let's say, communicate to the user that, you know, you are approving something which might be bad. All right, so this was the result. I told you we're going to see quite a lot of short clips. And this is to get the system alert window. Yeah. Our app starts again with 0, with not permission approved. So the message is totally, of course, you can change the message, but it's something which is far from the actual message. Yeah, and we have this permission approved, right? So simple. Okay. All right. So how we did that? Let's go to the technical part. All right. Which, like I said, is pretty much simple. So we're starting with our main activity with the onCreate method, where we are creating an intent. We're just adding this action here that I talked to you about in the previous slides. And where the first thing is to start the display on top, right? Which is going to trigger the Android settings app and start the display on top access menu. That's the first step. Then we're starting immediately another activity, which we'll call Trampoline, and will make sense after you see this, which will, again, in the onCreate method, will start a second instance of the display on top access menu. So what this will do is to bring our Trampoline activity in the onPause state. So it will just try to remove our activity from the top of the backstack, and we'll try to set it on the onPause state. But instead of staying there, we are going to start another activity, which we'll call overlay Trampoline, that will do the following. So in the first step, it will modify its user interface in order to cover the first menu dialog. So the user will click. So this will trigger the second step, but bring our own activity in the onPause state. So we can now modify our user interface, then again cover the second part of the dialog, and when the user clicks again, we can navigate the user somewhere else. So why we did that, why we are using that instead of something else? We are using that because, as I said before, we don't have, our app doesn't get notified about the touch, the user's touch. So we can't know, there's no way to know if the user clicked on this menu. So we identify that by the life cycle of the activity. We can see that when the activity goes on the onPause state, this means that the user clicked on the menu, so our activity went on the onPause state, and we can just, let's say, change and do all these things that we did before. So what I didn't cover so far is how we identify the current step that we are currently So we're just using an intent extra. We name it step. And then a simple switch case just to check in which step we are. So then we just modifying the message that we're showing to the user. We're modifying some parameters like the XY parameter that I showed you in the beginning. And we are creating the overlay. So this is the idea. Get the intent, get a window manager instance. As you see, we are not using any kind of special window type. We're just using a type application window. No permissions, nothing here. We're just modifying the settings like XY with this kind of stuff. And we are covering the parts of the dialog that we're interested about. That's for the first step. And then when we go to the on-pause state, we just increase our step one, let's say like one step more. And we're going to the second one, which we're covering the other parts. All right, like we saw in the demo. All right, so that was the main idea of the attack. But what we managed to take out of it? Which screens were vulnerable? So we managed to get all the dangerous permissions, like I talked to you about, like SMS, call logs, everything. Then we managed to get all file access. We managed to set our app as a device admin. As you understand, I couldn't bring a demo for each one of them, but yeah, we managed to get a device admin access, display on top of other apps, modify system settings, install unknown apps, and get usage access. So as you understand, when it comes to Android operating system, this thing is quite powerful. If you manage to get all these permissions for your app, then you have something which is, I would say, something like a malware on steroids. So it's quite big. What we didn't manage to get in this case was notification access and access to the accessibility service. That would be wonderful, but we didn't. Anyway, so okay, let's summarize what we have. So we said that the main idea, the design issue here is that the user can identify with which app, let's say, interacts with, right? That's the first issue. And the other one was when the activity is pushed in this backstack, it will retain its graphical user interface. The main idea was to integrate the user interface of the activity which is on top with the user interface of the activity which is below, and add click-through capability in order to hijack single-step decision dialogues, multi-step decision dialogues, and also third-party apps. All right, so that's how we can protect apps from this type of attacks. And the only way to protect an app from this type of attack, and this actually what was the mitigation regarding the system dialogues, is to check if the motion event which creates a click is partially or fully obscured. That's the only way to do that. So you get this flag, you see if this flag is, let's say, set, and if it is partially obscured, or if it's obscured, then you can just reject the specific click or touch. There is another way, but it can't protect you from this type of attack, but it can protect you from system alert window, which is the hide overlay windows that I talked to you about, and it was imported in Android 12. So you can use this one and use the set hide overlay windows method to protect your, let's say, activity from this kind of attacks, but again with special type of windows. And with that being said, that was the last one. Thank you very much for viewing this. If you have any questions, I will be happy to answer. Thank you.
Okay, thank you. Any questions? Yeah.
If you can go to the second to last slide.
Yeah.
What does it mean if it's obscured or?
Obscured means that it is covered from another window.
Okay, so there is a flag for this.
Yeah, it's a flag.
It's not used normally then.
What do you mean it is not used? It's a property of the motion event which identifies if this motion event, let's say, comes from it comes using a dispatch, to put it this way. So you are dispatching. It was dispatch.
Okay.
So that's what it means. Okay. Simply said.
Thank you.
Okay. Yeah.
Yeah. Here, your top right.
Where?
The top left.
Sure. Yeah.
So thanks for the presentation. Very nice.
Thank you.
This mitigation would imply that every single developer needs to do on every single touch event this kind of mitigation.
When it comes, of course, when it comes to, like I said, to critical decision screens, not everywhere, right?
Yeah, but still, this would not really protect you against the type of vulnerabilities that you showed, which were at the OS level for approving permissions, right?
When it comes to approving permissions, this thing has already mitigated, right? There is a fix, it has been applied, so there's no. I mean, if you try to run the same thing on the newest Android versions, it won't work. But when it comes to third-party apps, there is still an issue with that. You can use that in order, let's say, to create this kind of overlays. Although, I mean, you need again to bypass some restrictions, right? So you have to get your app, let's say, some kind of permissions in order to do that. But it still works. I mean, if your app doesn't have these flags set, it works.
So I was wondering, given that Google fixed this in the OS itself, are they planning to also fix it for third-party applications?
I don't think so, from the point that, I mean, they can't make you use these flags, right? It's something which is not, it doesn't stand from this point. And this is actually something which I have been discussing within my company. There are, let's say, some cases where you can't apply these flags because it breaks a lot of things, right? You know, when you're developing something and you're just changing a small flag which was used for something else, then it can break a chain of things, and this can be a disaster. So, like I said, you can use these flags when you have really important decision screens. Really, you can add them in your view, let's say your button, your tangle, or whatever, in order to protect it from this type of attack. That's the only thing you can do, I guess.
Yeah, but maybe the inverse should be applied. Maybe these flags should be the default, and then if you have a need...
Yeah, I don't know. Yeah, I mean, that's, you have to, the triangle, right? You have functionality, you have,
convenience.
Yeah, so, I mean, it's something that, I guess they leave it up to the developer to decide how they can arrange that thing there.
Yeah, okay, thanks.
All right. Thank you.
Any other questions? Yeah, there.
Hi.
Hello.
I wonder how could you make an phishing application that use the evil intent presented in the first slides, the evil intent mechanism without the user noticing the app while navigating between apps?
The first one, you mean the task switching, right?
Yeah.
Yeah, so this attack leverages the fact that the human eye can't, let's say, perceive the transition state from one activity to another due to the short transition time. So there is a very short transition time in order to see this. I mean, so the human eye can't perceive that. If we go back and you go very, very slowly, you can see the transition actually. But no, when it normally works, no, there's no way. So this is what this attack actually leverages, and actually this is something which is used by a lot of malware families in order to do such a thing. They're using this activity switch, in order to do that. Okay. So it is something which is valid. That's what I mean.
Okay. Because while you show the video about the evident mechanism, we could see the malicious app in the background while navigating between apps. So I wonder.
If you push it in the background. Yeah. That's a way to do that. But how many times you do that? When you have your banking app, right? You're just clicking on your banking app. I don't know. Yeah, maybe. I don't know if you are sometimes, let's say, very security focused. Yeah, I agree with you. We would do that. But honestly, I prefer not to install something. That's my first rule when it comes to security. But when you push the app back in the backstack, you can see which actually in which app it belongs to. But like I said, you don't see that.
But I wonder, is there a mechanism to phantomize, maybe to...
There are a lot of things that have been, let's say, introduced in order to show the user that, you are interacting with this app. Even there are some papers about it. But, when it comes to this stuff, I think so, I'm not sure, but I think that Google has to, let's say, put a balance between usability, that they don't want to interrupt the user, let's say, experience with, because, okay, there are some cases, there are some papers, they're showing something like, we can add, a bar here which says that you are interacting with this app. Like we have in Windows, for example, right? With which app you are interacting with. But no, here, there's nothing. At least for now, nothing. As far as I know. Yeah.
Okay, thank you.
Thank you very much.
I still have one question here.
Hi, hello.
Hello.
Thanks for the presentation. It was very interesting. So the last slide, not the last, but the one presenting speaks about mitigation.
Yeah.
What about common users mitigation or protection apart from good hygiene and not installing everything on Google on Google Play?
Yeah. Unfortunately, that's something, that has to do with, when it comes to Android, there are some specific, let's say, steps that you have to follow when it comes to security. Never, of course, that's the first one. The first rule, never trust an app which is off market. We never install an app from any source. You never know what. You know why? When it comes to a Play Store, at least they have some rules. You can't upload your app and request accessibility service without have some kind of, let's say, reasoning about it, right? When it comes though to off market, you can do whatever you want. Although there are mitigation, in Android 13, you can't request accessibility service when you are off market. Anyway, but what I want to say is that make sure that the sources from which you are installing your apps are, first of all, trusted, and then what kind of permissions you are approving. For example, the system alert window for me, it's powerful, right? It can bypass a lot of restrictions, and people, just approve it. There's nothing, because they don't know about it. So just approve this permission. It can give a lot of privilege to an app, right? And it can do all this kind of stuff, all this magic with the user interface. So you have to engage. You have to be careful with that. You have to check your sources. Yeah, that's the only thing you can do, I guess. All right. Thank you.
Other questions? Oh, okay. Still another one.
Yeah, I was wondering, first of all, thanks for the great talk.
Thank you.
I was wondering if there are any actual use cases for overlays that you know about, or is it about phishing?
Like I said, when it comes to overlays, when it comes to GUI confusion attacks in general, like I said, most modern malware families are using this kind of stuff. For example, you have Cerberus, right, which is very well known. It uses task switching. When it comes to this attack, no. At least so far, no. The one that I talked to you about, no. There's no, evidence at least that uses this type of attack, right? The ones that I show you.
Yeah, no. My question was not about attacks, but more legitimate apps having actual use cases.
If they're using
or being overlaid over
overlays. Yeah, of course. I think that actually the bubbles that you see in your window, in your device, like the messengers and stuff, they are using this type system alert window in order to do that. There are two ways in order to do that. It's picture-in-picture, which creates a small window like the maps. You use the Maps app. You just minimize it so it will go. This is a picture-in-picture, and the other one is using the system alert, which is a legitimate way. Yeah, that's for the legitimate way to use it to be on top of other apps. Yeah, so it's useless. It's useless. Anyway, yeah.
Other questions? Okay, perfect.
Right. Thank you
again
very
for the
much.
presentation.
Anyway.